Thanks for the great intro, Greg. So this being an election year, we've heard a lot about inconsistencies, but I'm going to talk about inconsistent advertisements in neighboring ASes, how to detect inconsistent advertisements from neighboring ASes, and our experience looking at these things from inside the AT&T network. This is joint work with Morley Mao from University of Michigan and Jennifer Rexford from AT&T. Okay, so of course, almost all of you have seen things like this. This is just an excerpt from a settlement-free peering agreement contract that I just happened to find on the web. Some people actually do put these things on the web. Something that turns up in these policies, these settlement-free peering arrangements, quite frequently is that the neighboring AS is supposed to announce consistent customer routes at all interconnection points. So what that means in simpler terms is that if you're peering with some AS, like you should expect them to advertise BGP routes at all peering points, and the routes that they advertise to you should have equal AS path length and equal med values. Okay, so why is this important? Well, again, you know why it's important. If an AS does this, then it allows you to do hot potato routing. You can shuttle your traffic off on the closest peering points, or actually wherever peering point you choose. If, on the other hand, a neighboring AS does not advertise these consistent routes, as I've shown on the right side of this graph, then it makes it a little tougher to do hot potato routing. For example, if AS1 sent a route on that peering session on the right with a longer AS path length, for example, well, then AS2 is going to have a little harder time actually implementing hot potato routing. Actually restricts the flexibility that you have in your policy in setting exit points. Okay, so we're concerned in trying to actually figure out why these types of inconsistencies happen. When they do, how can we actually detect them from inside our own AS? And then once we've actually figured out how to do that in some practical fashion, let's try to figure out how often this type of thing is happening. Is this something we should be worried about? So first, let's get to the question of why these inconsistent advertisements happen. Well, the first one is obvious, right? Your peer may be actually just trying to cheat you. That's simple enough. But the peer may not be sending inconsistent routes intentionally. There are a number of reasons why you might expect to see these inconsistent advertisements. Several of which involve misconfiguration, and I'll go into detail on these in the coming slides. And others sort of have to do with some fundamental limitations with regard to the interaction between the BGP decision process and how people implement business contracts. Okay, so let's first talk about the sort of simplest misconfiguration that could cause this type of inconsistent advertisement. You're probably way ahead of me already on this. If AS123 here that I've shown on the bottom, has different export policies to its neighbor, well, of course, the potential exists for these inconsistent advertisements to happen. Now, I've sort of given you just little snippets of Cisco iOS here, just to illustrate the point that looking at these configuration fragments to immediately detect the inconsistency isn't always obvious, right? Both of these routers may have configurations that say, hey, to this peer, use the route map called peer, and you may there's a typo here that should be actually, see, even I messed it up. The route map may say route map peer, set prepend whatever, and the route map on the other router may have the same name for that route map, but actually do different things. So these types of things may, this is the simplest possible case, right? But even these types of things may in some cases be hard to eyeball and actually immediately figure out that you've got a problem like this. So I'm just going to take this moment to plug a tool that I talked about at the last analog that I call RCC, which is the router config checker. And you can run this over your configurations to detect this type of inconsistent export policies quite easily. So there's a URL, you can go check it out. Please send me mail if you're interested in using it and helping me with it. Okay, so that's the sort of easiest misconfiguration that you can imagine. What other types of things can happen? Well, here's another pretty simple thing that could happen, right? So let's assume in my AS I've got 4 routers, and I'd like to set up full mesh IBGP, but whoops, I forgot an IBGP session from that router on the lower left to the router on the upper right. Well, so what can happen is, if route A comes in at this router on the lower left here, then this router on the upper right is actually never going to learn that route. So if this AS is peering at these two routers with some other neighbor, then at one of those peering points, that peer is going to hear route A, and at the other peering point, that peer is not going to hear anything. Okay, so you're probably thinking, what else could probably happen? Well, so let's assume now that some downstream AS sends A with some AS path length and another route B with a longer AS path length. Well, note here that you do have kind of a signaling partition here, because not only can the router on the upper left not hear route A, but the router on the upper right can't hear route A, but the router on the upper left can't hear route B. So that router on the upper left is going to advertise an AS path length route with an AS path length of 2. The router on the upper right is going to advertise a route with an AS path length of 3. And now, even though that neighbor is going to hear routes at both of those peering points, it's going to hear things that are inconsistent, i.e. they have different AS path lengths. So you're probably thinking like, oh, come on, like this, this sort of IBGP like failure to configure full mesh like never happens, right? But these things can actually get like significantly more complicated when you start introducing things like route reflection, right? So here I've basically dropped in the simplest possible IBGP signaling partition involving route reflection, right? I've got a top layer of 3 route reflectors, but they're not fully meshed, and I've got the same situation here again. So one thing I want to stress here is that, again, unless you specifically look for this type of thing, this may be going on and you may not even notice, right? It's not like reachability is being affected here, right? That peer, whoever you're sending these routes to, is going to hear routes. They're going to be able to reach the destination. And unless they actually take the time to look, then hey, this stuff may be going on and we may not know about it. And similarly, like you may be doing this to your peers and not know about it if you haven't bothered to check for this type of thing. So again, RCC can look for these types of signaling partitions as well. So what other types of things can happen? Well, a lot of these inconsistencies can also be caused by things like BGP communities. Let's say the same AS is now fully meshed, but it's got some customer that's advertising route to a destination at 2 places, and maybe at one of those places the customer attaches a no export community. Well, the routers in this AS may not all pick the same route. The router on the upper left may pick route A, and the router on the upper right may pick route B. Well, so what happens when that router on the upper right picks route B is that route has a no export community and it doesn't send the route. Okay, so those are sort of things that involve configuration. Let's talk about some sort of more fundamental limitations that can cause these inconsistencies to happen. So just supposing for a minute that we abide by that common restriction that if an AS learns a route from a peer, it's not going to re-advertise that route to another peer. Well, strange things can happen if you prefer customer routes and peer routes to a single destination equally. So in this example, I've shown route A coming in from customer 1 and route B coming in from peer 1. Well, so what happens now is if that router on the upper right picks the peer route and the router on the upper left picks the customer route, well, peer 2 up there is going to learn route A from the upper left, but not route B. Now, you may be thinking like this is incredibly contrived and perhaps I've just made this up, right? Well, let's open the Nano history books. And Randy Bush isn't here, unfortunately, but I'll speak for him anyway. We go back to 1997, we can see this situation that I just described to you on the last slide actually came up on a thread on the archives. You can go read the thread yourself. Essentially, what Randy is saying here is that, hey, I've got some site that I'm learning routes to from both a peer and a customer. I have consistent export policy, but because I'm not advertising my peer routes to other peers, the situation I just described actually can happen. Okay, so now that we know like the types of things that can cause these inconsistencies to occur, let's sort of dive deeper and try to figure out how we can actually detect these things. How can I actually figure out is an AS sending me inconsistent advertisements? Okay, so the first thing you might think of is really simple, right? Well, if I'm hearing routes A and B from some AS, well, why don't I just look at the routes I'm hearing over eBGP and compare them, and if they're different or if one's missing at some peering point, then I go yell at them. Well, unfortunately, this type of thing isn't tenable today. You kind of imagine how you might do this, right? Unfortunately, we can't actually see the eBGP routes, all the eBGP routes that are coming over those sessions. You'd need something like a vendor enhancement to say, like, allow the router to say, give me all the routes I've learned via eBGP at a specific time, right? I can't just do show IBGP, for example. Like, I can't do table dumps because, hey, that table dump could take 10 minutes, and if I'm dumping routes from both of these tables over a 10-minute period, I don't know if that inconsistency actually happened or it was some like transient event that was going on while I was dumping the tables. So I really need like some sort of real-time feed to do this correctly. One way to do this would be to require the vendor to actually tell me all the BGP routes, all the eBGP routes I'm getting in real time. Of course, another way you could do this, assuming you trusted your peer and it wasn't actually doing that in this inconsistent advertisement intentionally, is you could say, hey, could you send me an eBGP feed of your routes at a separate router so I can actually monitor them? That doesn't, that approach doesn't really instill a lot of confidence in me. The third is, of course, you could take packet monitors on every one of these links and then see what's actually coming on those eBGP sessions. So it's unfortunate that we don't have any of these things, because this problem would really go away if we could get just one of these things. So what can we do instead? Well, we can monitor the IBGP. It's really easy, right? Like, we just set up a Zebra router or some other type of monitor, and we just start logging the IBGP messages. We've got timestamps on them, and we can figure out what routers, which of these border routers have picked which route is their best route at any specific point in time, and then I could look for inconsistencies. Well, the problem with looking at the IBGP is I don't get the full picture, right? I only get each router's best eBGP learned route at any one time. So, for example, in this AS I've shown here, if the router on the upper right picks route C, then I only get to see route A and route C. I never get to see route B. So it's tough to tell whether routes A and B are equally good if I never see B. Right? So what can we do about this? Well, let's try to infer something about B. Even though we didn't see it, because we saw route C, maybe we could say something about route B. Okay, so the trick here is to basically try to, and the other problem with IBGP, right, is not only is that each one of these routers picking its best route, but there's policy going on there too. So the routes I hear over these IBGP sessions may be altered by the import policies on the eBGP speaking routers before I actually get to see them. Right, so what I'd like to do to allow me to compare routes A and B is to sort of say something about route B based on the fact that I saw route C instead. So what I want to do is take this route C that I've learned over IBGP and sort of figure out what it would have looked like over the eBGP session by inverting that import policy. And then I'd like to be able to say that, hey, since this router is picking its best eBGP learned route, and I learned route C, well, C must be at least as good as route B, because otherwise I would have heard route B. And then, knowing that, I could say, if route C is worse than route A, then either B also has to be worse than A, longer AS path length, etc., or B wasn't advertised at all. Otherwise, I would have heard it. Unfortunately, I can't always do this. Certain things have to be true about the import policy to allow me to make these kind of statements. Now, on the last slide, I talked about inverting import policy. So the first thing that has to be true about import policy is it has to be invertible. And the second thing is that the import policy on those eBGP speaking routers can't take two routes that are consistent, i.e. they have equal AS path length and they're all being advertised, or the peer is advertising something at all those peering points, and actually make some set of consistent routes look inconsistent. So I'm going to talk about examples of import policy that violate each of these two things now. So here's an example of a non-invertible import policy. Let's say that on both of these border routers, I have some import policy that says if the AS path length is 1, then prepend 1 twice. If the AS path length is 1, then prepend 1 a single time. Well, what am I going to hear at this monitoring point if I hear 1 on this session on the left and 1 on the session on the right? I'm going to hear 3 1s for my AS path in both cases. And I could flip-flop these, and I could also, they might also be both AS path length of 2, or they might also both be AS path length of 1. There's absolutely no way to tell because my import policy has done something that doesn't allow me to reverse it based solely on what I see in the IBGP routes. Okay, so the other thing that import policies could do, potentially that would make our life difficult, is to take two routes that are consistent in terms of AS path length and make them inconsistent. So let's say that these border routers now have some import policy that says, if the AS path contains the AS5, then depref the route. Okay, so what could happen here is that, at this router on the upper right, if that router learns a route with the AS path, for example, 156, and a second route from a different AS with a longer AS path length, well, then that router is actually going to choose the route with a longer AS path length. So what we're going to see at this monitoring point is a route with an AS path length of 3, 146, and a route with an AS path length of 4, 2786. But I can't say anything about what I would have heard or what I think I might have heard from AS1 on this other border router, because my import policies are making it impossible for me to see actually what's going on. Okay, so these are two cases that create some problems for us. But in other cases, the technique I described to you, or the logic I described to you for inferring what's actually coming in over the eBGP sessions actually does work, and we can answer some questions about how prevalent these types of inconsistent advertisements are. Obviously, the first thing we'd be interested in is trying to figure out how often these inconsistent route advertisements happen. Of course, another thing to think about is how long are these inconsistent route advertisements lasting? If they're relatively short-lived, then we could probably write it off to convergence or something like that. If, on the other hand, they're going on for days or weeks, then it's probably time to make a phone call. And then the other thing to think about is, how badly are these inconsistent advertisements messing us up? Are they causing us to send traffic, from out a peering point in San Francisco instead of one in LA, or are they causing us to send traffic out of a peering point in San Francisco instead of one in New York? Just things to think about when we think about inconsistent advertisements. So let's look at the first one. How often are these inconsistent route advertisements happening? Well, we looked at a week-long trace. This is so I'm going to show you two types of data. I described the easy case when we had the eBGP feed, and we did have this for one of AT&T's peers. And that's what I'm showing here when I show BGP announcements from one peer. So we looked at a week-long period of this trace, and just looked at, how often was it for the case when a prefix was being advertised? How often was it that, it wasn't being advertised at all peering points, or it was being advertised at all peering points but had different AS path lengths, et cetera? And you can see that over the course of this week, inconsistent route advertisements are happening all the time. So you might wonder, what's going on here? So let's, is that always the same prefix that's being inconsistent, or is it just short-lived stuff? Well, it turns out almost all of this stuff is short-lived. You can write almost all of it off to convergence. 99% of these inconsistencies last less than about 100 seconds. But there are, some fraction of these routes that are inconsistent for the entire period of our trace. As far as different AS path lengths are concerned, that seemed to be even less prevalent. Again, these types of inconsistencies are quite short, and these types of inconsistencies we didn't witness in our trace. So this was actually, keep in mind, this is not a general result that I just showed you. This was for one of AT&T's peers. But for this case, it's pretty safe to say that most of these inconsistencies are caused by convergence, but not all of them. And it's important to look out for that 1/10 of 1% to actually see what they're doing. So let's sort of drill down and sort of figure out what's going on with those inconsistencies, which prefixes are being inconsistent for how long. Okay, so what I've shown here, the way to read this graph is on the x-axis I have percentage of time, so that's duration of time for the trace. So and it's a log scale, so 10 to the 0, i.e. 1%. That would be 2 hours roughly, and 10 to the minus 2 is essentially a minute, right? So if we read up from, for example, 10 to the minus 2, we can see that for this peer, 85% of the BGP routes, or 85% of the prefixes had less than a minute during the entire week for which they were inconsistent in the sense that they weren't being advertised at all peering points. That's what missing means in this case. Okay. And you can read up, for example, from 2 hours, right? And it's basically like 95% of the prefixes were consistent for all but 2 hours of the week-long trace that we looked at. Okay, so you might be thinking, like, is this just a well-behaved peer, right? What about other peers? Well, I did take the IBGP technique that I described to you earlier in the talk, and for those peers where we didn't have eBGP feeds that we could look at, we looked at some of the IBGP stuff. And most of the peers look like the one I just showed you. So for the graphs that we just looked at in detail with the missing and the different AS path length, that's shown here as peer 3, the green line. So what I've shown here is I basically combined both cases of inconsistency, different AS path lengths or not advertised at all peering points, and just called that an inconsistency in this graph. So again, you can read this graph in the same way. So up here basically means that almost all of the time, like, these prefixes are consistent, and down here you've got a significant fraction of prefixes that are inconsistent for a large portion of time. So what's going on with this peer 4? Well, that's probably someone we should make a phone call to, right? Because it looks like about 15% of the time, 15% of the prefixes are inconsistent for more than 70% of the trace. That's like 5 days out of 7 days. 15% of these prefixes are inconsistent. That's probably not convergence. Okay, so just in conclusion, these settlement-free peering arrangements are occasionally violated. Most of these violations we can explain away with convergence. But there are a few significant cases where it's probably worth looking to see if you have this type of thing, and if it's actually affecting the way you're routing traffic in some severe way. So I did describe for the first half of the talk some way that you can actually detect these violations without modifications to routers or having to have packet dumps on all your eBGP sessions. You can do this with simple IBGP monitoring for a lot of cases. Of course, if we had this monitoring protocol that dumped the eBGP routes, this problem would be really easy. So there are a lot of people from Cisco here, and I hope they heard that. So another thing to take note of is that there are quite a few of these inconsistencies, thousands in a week-long period. And most of the time, for the things that we observed, the inconsistencies that we observed were mostly due to missing routes, i.e. a route not being advertised at a peering point where it should have been, rather than different AS path lengths. Most of the time, peers seem to be well behaved, but there are some peers that we should watch out for. As I mentioned, there was one case we observed where more than 15% of the prefixes were inconsistent for 5 days out of 7 days. So thanks for listening.
Okay, we have time for 5 to 7 minutes.
Sure.
As we were talking about yesterday, one of the things that we've seen is when you give
Avi, you're supposed to introduce yourself.
Avi Friedman with Akamai. One of the things that we've seen is when you give customers flexibility by giving them communities, they can cause inconsistent announcements. So on your slide you showed no export, but for example, if you have a PNI only community and you happen to peer with one AS, not at PNI and at PNI elsewhere, that'll cause inconsistency. And if you take a look at a lot of policies, you can actually look at some of the larger transit providers. You could construct ways to do this inconsistency. But it is those larger transit providers who are generally the ones most interested in getting consistency. So in many of those cases, if they just set up, peering 2 zebra boxes to do internal monitoring of customers, applying policy that cause inconsistency, that might actually help.
That's a good idea. Yeah.
Actually, I'll ask a question.
Sure.
So, I understand some of the limitations of inferring via IBGP. It sounds like the real problem you're trying to solve is really understand if someone is, the ultimate problem is someone intentionally gaming you or redirecting traffic flows. It sounds like
Absolutely.
it might be
Yeah.
actually easier to do something, actually looking at the traffic itself that's chosen. If you can't get a real live, adjacency rib-in feed, perhaps looking at the IPs from via NetFlow or other measurements and actually seeing the actual traffic chosen or selected on the outbound interface.
That is a good idea, and it's another way to look at it. That problem's probably worth exploring. I expect that. I mean, one good reason to look at the routes is because it's pretty easy to separate the cases of convergence versus those that are clearly not convergence. Now, I'd be interested to see if you could do the same thing from traffic. Is this just a transient, like, traffic fluctuation caused by a change in demand, or is it due to the way I'm sampling my NetFlow, or is this actually something I should be worried about? And you probably could do it with traffic too.
Okay. Anyone else?
Thanks.
Okay, thank you.